Okay guys, welcome back to my YouTube channel. Again, this is your host, Santos Capelan Jr. Always wishing you a good day. Guys, today what I'm going to do is to show you how are you going to test the valve, actuator, and the valve automatically. Okay, so first, what do we need to test it automatically? First, of course, we need to connect our control or our valve control to our analog output module. Okay, so I have here my analog output module. As you can see, I already terminated my let me show you it. Okay, let me focus. Okay, so I have here my analog output module. Okay, so hopefully it is already clear. Okay, now let me show you. Now I connected it to my output channel number 5. As you can see here, I'm using the VO, that is voltage output, then the common. Okay, so this is our control signal. Okay, so this analog output module will give a 0 to 10 volts output signal, okay, based on our control logic program. But by the way, we are going to use a simple PID block here to control our valve. Okay, so then again you need one temperature sensor. Okay, so I want to use a temperature sensor. Let's say this is our supply duct temperature sensor, because I want to simulate my control for an air handling unit chilled water cooling valve. Okay, so we have cooling coils where we control the flow of chilled water inside the cooling coils through the valve, and we are modulating the opening and closing of the valve so that we can control the temperature being delivered by the air handling unit. Okay, so guys, another thing, you need to connect the feedback to our as you can see, I have here my universal input module UI16. So one of the channels I connected the temperature sensor. Okay, then I have here a glass of water wherein I will try to dip the sensor probe to change the temperature, because this one is sensing the ambient condition or the temperature in this area. Okay, so please try to bear with me because I'm doing my video outside. Okay, now, okay, so let me. Then the other thing that I need to do is to create a simple graphical user interface, so a BMS graphics to show that, because if you are the BMS engineer, let's say you are in the control room, then these valves are located remotely. Maybe the air handling unit is in the rooftop of the building, so you are in the BMS room and you are just looking at the operation of your valve in the graphical user interface. Okay, so let me focus you in my graphical user interface just for a while. Okay guys, so this is my simple graphics that I have created beforehand. Okay, so let me just show you how we are going to do the simulation. Okay, now guys, this is my let's say I have my air handling unit. Okay, I'm just showing a portion of my air handling unit. Okay, as you can see here, this is our cooling coil. Okay, then we have the valve and our valve actuator. So we have also our valve and we have our valve actuator. Okay, so I hope you can see the movement of the valve stem. Okay, so I will put this there. Okay, then you can see also the opening and closing of the valve by looking at the knob, and also the movement of this valve stem up and down. Okay, now I don't know if I can still sorry. Okay, so let me just sorry for that one. Okay, so anyway, so I'm just want to focus you with the valve stem and also the graphics here. Okay, so wait a minute, let me reposition this. Okay, so guys, let me explain again. I have my temperature sensor here. So this temperature sensor, the current temperature that is being sensed by my existing temperature sensor is around 30.9, because I'm filming here or I'm recording here at my garage. Okay, so as you can see, also you can see me at the background, so sorry for that. Okay, Now, what is important here is to explain to you how are you going to test the valve in automatic, okay? Now, this is a closed loop control, okay? So, I'm trying to control the valve opening and closing through the use of a PID controller, okay? Now, PID controller is proportional plus integral plus derivative control. So, meaning there are three components, proportional plus integral plus derivative control, okay? Now, this is just a simple temperature control. When I say temperature control, we just want to control the temperature here in this area. Let's say this air handling unit is supplying or serving an area in a mall, okay? So that area, we want to say the temperature there should be at 26.5, okay? So this is our set point, okay? So let me adjust the set point. So I will adjust the set point, okay? So there's a way to set the set point. Now I think maybe we can say 23 degrees is cold enough for an area in the mall, okay? So that is also already comfort cooling. Now my actual temperature, let's say the air handling unit has just started, so I have 31 degrees there, okay? Now as you can see, the valve control signal or the valve or my PID or my PI control output is 10 volts or 100%, meaning I want the valve to open fully, okay? Then my feedback here is 96.5, meaning as you can see, there is some discrepancy here, 3.5, because we are expecting if it is 100%, then it should show me also 100% here. But I can solve this one by putting some offset, okay? I will put 3.5 offset, then this one will be equal, okay? Anyway, I will show that to you later, okay? Now, the air passing in this cooling coil is being cooled by a chilled water, okay? So there is chilled water entering this coil, okay, through the control of the valve, okay? So the more chilled water will enter here, the more it can pull down the temperature of the air passing the cooling coil, okay? So this is a very good example of control or a closed loop control in a feedback and control subject, okay? So shout out to my students in feedback and control, because in a feedback and control or in a closed loop control, you have the desired value or desired set point, okay? Then we have the measured variable. So this is the set point or the desired temperature. Then this is our measured variable or the temperature itself in that area. Then we have our controller output. Then this is the feedback, okay? So this is the feedback, okay? So how are we going to test our valve automatically, okay? Now there are several ways. Let's say now my valve is open at 100%, okay? Because my temperature is 31. Now I can simulate, let's say maybe I want a higher temperature there, okay? Maybe I am in Europe. I want a higher temperature there, okay? So you will see the valve is responding here. So that is another way of checking the valve. And you can see also the valve is responding here. You can see here the valve is opening and closing, okay? So now the valve is opening 57, still actually it will try to open because the set point is 26.5. Now there's another way. Let's say I can force this one. There's something we call forcing of the point. Now I can force it, then I can say, okay, so I'm forcing it 27, so this one will show 27, then the valve should respond accordingly, okay? So, but that is not, this is just to show you how the valve responds to sudden changes or disturbance in the control. Okay, so let me remove the forcing, okay, unforce it, okay. Now, let me try to simulate it by playing with our temperature sensor then, okay? So first, let me show you how I'm going to do it. Now I can immerse it. As you can see, I'm trying to immerse my, okay, you see the temperature is changing there. Okay, focus in the graphics, okay, and the valve responds, okay. Now, because this water is cold, okay, then as you can see, when the temperature rises, my valve will try to, okay, there is a small change there. Then as you can see, now my valve will try to open because there is a small error, okay? The there will be an error between the set point and the desired temperature. Okay, so let me put it here. Okay, now as you can see, the bulb is responding accordingly. Okay, so hopefully my video is still clear at your end. Okay, now this is how you test the bulb. So the bulb should jibe. Let's say if you have 65 here, then the bulb should also respond accordingly in the side. Now my control is opening the bulb, so as you can see, the bulb is also already 100% open. Okay, so if we will try to dip it in a cold water, then again the bulb will respond accordingly. Okay, so guys, this is how you are going to test your bulb actuator and your bulb using a PID controller. Okay, now guys, actually the BMS engineer, you need to check after finishing your control. You have to check your control how it responds to the real scenario in the field. Let's say the air handling units are already installed, and you can test it by playing with the valve. Okay, I mean, it is ready for testing, then this is how you are going to do it. Now if you see that your valve is, the control is not smooth, or the valve is suddenly opening 100% then suddenly closing like this, then you need to adjust your integral time. Okay, so in a PID, or if you are using a PI, all you need to do is adjust the integral time. Okay, because the integral time will be the one to smoothen the response of your PI controller. Okay, so anyway guys, again, I hope I have shown you already how are you going to test it in automatic mode. Okay, so again, if you are new to my channel, please help me promote my channel by subscribing. You can also click the notification bell, then you can also like, share, and put your comments. Okay, again, I'm doing this to help new engineers who are wishing to join MEP, or those who are joining the field of building automation or building management system. So before I will end, God bless us all. Let's all be safe, and bye for now.